this problem using place value. This problem using cross out. This problem using no. But it's just the words. You know the words.
It was 40, but how am I going to put 40 up here?
Let me see. Which one? Well, first of all, look at your dividend. Your dividend and your divisor. So if you're dividing 40,000 by 1, how many times can 1 go into 4? So that's your first mistake. 1 times 1 is 4. You see it? So let's work on that. Huh? Oh, it's okay. So, just that. What is that? It's a 1 still. Now, which method do you use for that? For 40,000 divided by 100. Which method did I use? I used what? No. Face value chart, right? Which method do you use? What's this called? The standard algorithm of division, right? So we have the standard algorithm of division, but if I choose to start no. Stick to the place value chart. Or, okay, so what about number 2? The cross out method. So try the cross out method. Let's try it. Rewrite this and standard I understand that, but standard algorithm, when you get into long division, it's really for those numbers that cannot be divided easily by a multiple of 10. All of these numbers up here are easily multiplied by multiples of 10. Because 100 is a multiple of 10, that's why it's 40,000, right? But when we use the long division, the standard algorithm, it is primarily used for numbers where we can't just break it down by a multiple of 10. So now that you have this, 40,000 divided by 90. Which one? So try to cross out method. I'm going to give you 2 minutes to try to cross out method. That's 10. It's divided by 10. It's divided by 100. So try that and then come up with an answer. And then we'll go back in 2 seconds. Because, let's look at this. If I go to 5,000, I'm using place value chart, right? Each of these places are divided by what? 5,000, this is 5, 1,000, right? So 5,000 divided by 5 usually. This is what we call, we're getting into partial quotients. So, pause to the students right quick.
Pause to the teacher.
Alright, let's talk about something. So, Helen had a really good question about Ronaldo, Taylor. So, Helen had a really good question. She said, well, Mr. Davis, when I do this, how is it that she did the long division thing? And I showed you guys this here for misconception. We haven't gotten to long division yet. Excellent, that you already know, but we haven't got, good job. Because in 4th grade, you started long division with remains. However, we have not gotten there yet. Not to say that you don't know how to do it, but we haven't gotten there. So we're using a place value chart to make this known. So she said, well, Mr. Davis, how is it that 50 is up here instead of just a 5? Because when we look at a place value chart, and remember, how do we draw a place value chart? 5 lines, horizontal, and then 4 lines vertical, right? So we started the 1s, and I'm gonna just use numbers this time. 1s, 10s, 100s, 1000s, and 10,000s, right? So we plot this number. Let's look at this. We started with 51,550. And we used the decomposition method, which is basically taking what?
0, 1 away.
Not taking 1 away. The decomposition method is what? Not shifting. What are we talking about? If I took this 50, the divisor, right? Decomposition method is when we take the divisor and we decompose it. Chagozo, how do we decompose 50? 10 and 5, because 10 times 5 is what, man? 50. So instead of, good job, Daniel. So instead of us saying 10 times 5, we're going to divide the original dividend. I'm sorry.
Wait, what's that method?
Decomposition method, right? So we're going to divide, once we decompose 50, the divisor, into 10 and 5, we're going to divide, because we have a power of 10, we can easily shift these digits. Right? So when we shift this digit, these digits by how many places? I'm gonna get there in a second, okay? So we divide this by 10 and we shifted the digits one place to decrease the value because when we divide, we decrease. So what is this number gonna be now? 5,155, correct? I'm gonna get there. So now we still have what left over? The 5. So we have to divide our quotient, which is a partial quotient, to what? By 5. So we have 5,155 divided by 5. Now, this is where the work comes in. We could do the long division way, but unfortunately, we have not learned that yet. So we're going to use the place, hold on, hold the question. We're going to use the place value chart and divide each place the same way that we shifted the digit by 10. Each place is going to be divided by which number? Essentially, the original number, each place would have been divided by 50, but each place is going to be divided by what now? Because we've already dealt with the 10. So now, 5,000, and this is where we get into partial quotients. Please write this down on the paper. Partial quotients. You guys know about partial products, right? Yeah. Partial quotients is what? If partial products is, once we're multiplying place by place and we receive a partial product for that place, or a product for that specific place, what is a partial quotient? Helen?
So I think that
it is a term, it's a mathematical term. What does it mean? When I say I have to find a partial product, quotient, I'm sorry. Yeah, this is the definition of a quotient, the solution to a division sentence, yes. Very, one term, explain term. Good job, good, great try. What does the term mean? Can you explain term? You want to think on that for a little bit? Then I'm going to ask someone else. Nakira, what do you think of partial product is? Keep thinking about that, please. I'm sorry. Partial quotient. I'm sorry, it's the same product, guys. Partial product is basically when we're multiplying place by place, and you receive that partial product, that partial answer, not the whole answer, but that answer based on that place. So what is a partial quotient?
I think a partial quotient. So what I think it is when you try to when you try to find the answer, like when you try to solve the answer with with division. I mean, not with division, but like a partial quotient is like when you don't when you're doing the matter again, and then after that you try to find out what's the answer.
Okay, we're getting so there. Helen, I'm going to come to you next to tie it up. Let's see who we got. Chijindu, let's see.
I think the partial quotient. I think the partial quotient is based on the people. I think the partial quotient is when you break down one of the numbers that is the big number that you're dividing by, or dividing by.
Okay, I like that terminology. You said when you break down, good job. You said you break down one number in a place based on the number that you're dividing by. You're going to do that for each place? Is that what I'm hearing from you? Okay. Helen, let's bring it home. What are we talking about? What is a partial quotient? What does that term mean?
I think the term means
a unit? What kind of unit? What are you explaining? Let's look at this. So this is partial quotients. Hopefully you guys wrote this down on your paper. You had 5,000 divided by 5, 100 divided by 5, 50 divided by 5, 5 divided by 5. What does this look like? What did I do here? Dave, come back to you now. I'm breaking down timetables of 5. I'm breaking down what? Where did I get 5,155? I'm decomposing the larger number and dividing it by what? 5. So I'm going to take each place. In a sense, it's very similar to the distributive property. Because when we have a distributive property, we're distributing each factor to each factor so that we can come up with a partial product. That is exactly what, partial product is exactly what you have. partial quotient is when I take this number, I decompose it by place, and I'm going to divide it by the original divisor. And that is going to give me a set of numbers, or a set of quotients, partial quotients, because that's not the total quotient. So let's see, 5,155. How many thousands is it? 5,000 divided by 5 is what, guys? 1,000. Very simple, right? 100 divided by 5 is what? Which number times 5 can give me 100? Think about it. Use what you know. 10 times 5 is what? So 20 times 5 would be what? You have it on your paper. So how many times can 5 go into 100? 20 times. Oh, they line that up properly for you guys. 20. 50 divided by 5 is what?
10.
Perfect. And then 5 divided by 5 is what? And then we're going to add up all of these quotients and we get 1,000. 1,031. So, what is partial quotients very similar to? You already learned. Distributive property, what else? I'll come back to you. What is partial quotient similar to? She said distributive property, what else? Breaking down numbers and decomposing them, what else? Area model is per se, because you can actually, we'll get into that. What else? And it's good to study algorithm as well, because guess what? Now let me take this X off here. Let me take this X off here. When you say 5 goes into 5, and we said, and this goes back to that question, you said, well, Mr. Davis, why is there 50? Helen, you asked that question, right? You said, why is there 50 instead of just putting the 5? Because this is the same as doing a partial quotient. Long division is partial quotients. Back and forth is solving each place by place, finding the quotient of each place by the original divisor. What did I skip? 5,155. That was my number, right? 100 divided by 5 is what? Okay. So, ladies and gentlemen, I want you guys to... Yes, that's what they find answer. Yes.
Oh, what happened to the 0 and...
We talked about this.
What happened to the...
We talked about it. Because we did partial product. Partial quotients, I'm sorry. So listen.
So if it ends with a 0, you lose?
No, that's not what we did.
Oh, yeah, I get it.
Gotcha. Okay. You sure? Yeah. Alright, so ladies and gentlemen, I want you to open back your books up to lesson 16. Number 2. I have some of your books. So I want you guys to go to number 2. Whose book do I have over here? Kira, yours. Taylor, yours. Helen, yours. Pass it. Take your book, pass it to the next person. Jose, yours. Ronaldo, yours. Shajingo, yours. Page 227, please. 227. 227 should give you lesson 16, number 1. It's okay, man. It's okay. You're almost out of these books. Excuse me. 227. You're going to see number 1 for lesson 16. Yep. 227. Now let's put some of this knowledge to work. We have a place value chart as our first type of way to solve. The cross-out method for 2, and the third is decomposition. When you look at question number 1, 1A. 1A. How can we solve 1A? Who can tell me which method should we use? What's the appropriate method? Daniel. What's the appropriate method? We have 3 of them. What's the appropriate one to help us solve 1A? Outside of the standard algorithm, because we have not learned that yet. Well, I have not taught that yet. That's not we have 3 methods. Place value chart, cross-out method, decomposition. You can do cross-out method. Do you agree?
Yes.
Okay, let's look at 1C. 1C. What method? Don't tell me. Show me in your book, please.